All right, friends, let's keep going with trig functions. In our last lesson, we looked at the period of sinusoidal curves, part 1, and now we're going to look at sinusoidal curves periods, part 2. And a great place to practice here would be 38 to 40, and you can look at go formative these key questions to make sure you know what you're doing, and this is great practice, and I would call essential practice. So here we go. We're going to take our second look at the period of cosine functions, part 2, and here we go. So we're going to finish off this today. We looked at part 1 last time, and we'll look at part 2 today. And we need to just look at different ways of considering period. There are many things that are periodic. You might not have seen the sun and the moon as periodic functions, but here you go. I always think this image is very interesting. Other things that are periodic are waves. So tidal waves are periodic. They have a high and a low, and they move through the ocean, as you can see. This is a great clip, and I hope you'll take a look at this clip in the slide deck, just all the mysterious ways that sine waves exist. Okay, so what I want you to do is answer this question. Can a period be exactly 4 radians long? How long are each of these? Pause the video, and then let's check in. Okay, well, we can see that this one starts at an average, goes down, and right there I can see that that is 8. So this one has a period of 8, and this one has a period of 6, and this one has a period of 16. So I don't know about you, but I would much rather play with periods that are 8, 6, and 16 rather than things that are portions of pi. So that's what today is about. Is pi is still in there. Pi radians is still there. It's just that. And here's 6.2 radians, which is just a little bit more than 6. So what we're going to do today is figure out how can we take control of these graphs and create functions that are easier to play with. So let's do this. Let's go ahead and see if we can figure out what the period of each of these are. I want you to be looking for a pattern, because by the end of this section, you'll be able to look at these and know exactly what the period is without doing too much work. All right. So this one, the period is 8 pi, and the reason we know that is we just take the period, 2 pi divided by b, and the b value is 2 over 8. If we multiply that fraction both by 8 and 8, you'll see that the 8's cancel. So do those 8's would cancel, and then those 2's cancel, so you're going to get 8 pi as the period. There's not a pattern there to see yet, but there is a pattern on this next one. Take a peek at this. 2 pi divided by b, 2 pi divided by 2 pi over 8. When we multiply both of those by 8, again, the 8's cancel, the 2's cancel, the period is 8. That's really classic. What do you think the period of this is? It's 17. Why is that? Pause this video and just look at this pattern here. What do you think the period of this would be? Well, if you thought 87, you're right, and here's why. And you can pause the video to look at this pattern again. Okay, what I want you to do is write a sine wave with a period of 19. Pause the video and do that, answer all these questions, and then check in with me. So one way of thinking about this here would be that the period is 2 pi over 19. How do we know that? Well, if we have 19 equals 2 pi over b, rearrange for b, we're going to get the b value being 2 pi over 19. Well, this one, I bet you can do that in your head now. That's 2 pi over 77. You're going to have to go back on this one, but again, this would be 12 over 5, and here's why. 5 pi over 6 equals 2 pi over b, rearrange for b, and you get 12 fifths, and there's your b value. So hopefully you saw that pattern. Now, what we're going to do is just get some practice, more practice writing equations. And this is a very important section, because in the next section, we're going to be looking at applications of and word problems and contextual problems, which requires you to be a master of graphing and writing the equations of graphs. So let's take a look at this one. Can you see what the vertical displacement is? Sure looks like 2 to me, and if the vertical displacement is 2, then the amplitude is 2. And so when we look at this equation, we see the amplitude being 2, and that's 2. When I see what the period is, it's 1, 2, 3, 4, 5, 6, 7, 8. So that's why the b value is going to be 2 pi over 8. And remember, a sine wave starts at an average and goes up. So I'm looking for an average that goes up. There's my average, it goes up. That is a y value of 7, so that's why the phase shift is it's theta minus 7. Same thing with the cosine. As always, the vertical displacement is the same, the amplitude is the same, the period is the same. The only thing that's different is the phase shift. And so when I look for this, I'm looking for a cosine at its lowest point. There's the lowest point. It's clearly been shifted over 5 units to the right, and that's why it's theta minus 5. Okay, so again, we're going to get a bit more practice here. So why don't you try these ones if you need more practice? Pause the video and let's take a peek. So we can see that the vertical displacement here, there's our average right down there at -3. And if I go up 4, there's my amplitude. So I got a -3 and I got a 4. The period here, if I count over, I can count all the way to 12. That's why the period is 12, so 2 pi over 12. And it's a sine wave and it's going down. So I'm looking for an average and it's got to go down. So I can see that the phase shift there is x minus 1. The cosine wave, again, same vertical displacement, same amplitude, same period, and the phase shift is 10. So, excuse me, I'm looking for a maximum, and I see that maximum at 10, and it's been shifted from there all the way over to there. I can see the phase shift is 10. Alrighty, so now we're going to get some practice graphing. I'm really nervous about trying this again. I'll try. I'm going to use this grid to help you see what we're thinking here. So here's how I would see it. We know that the vertical displacement is 25. So I'm going to draw a line at 25. And we know that the phase shift is 5. So that would be up 5. So what I basically need to do is from this point right here, I just need to graph this function right here. Now I notice here that the period is 20. So what that means is if I count over 20 all the way over to 25, which is about right here, it's going to start there and end there. So halfway in between 20 and 25, I'm going to be at 15, which is right here. So once I know that, I kind of have a general sense. Since this is a negative function, sine wave usually goes up first and comes down, but we know that this is a negative function, which means that it's going down first and then up. So basically, if I know that, then I know that halfway between these two averages, I should be at a max, but it's reflected. Usually the maximum would be at 1, but the amplitude is 15, and that's why we have this at 15 down and 15 up from there, which allows us to get sort of the sense of what this guy looks like. And I did a way better job of this than in the last lesson. So if you want to see a really bad explanation, go to the last lesson and you'll see it there in living color. All right, so I think that's good. Let's clear, we'll clear the screen here. Hopefully that clears. It's not clearing. Why is it not clearing? Just when I thought it couldn't. Okay, good. There, it's gone. Great. Okay, create a cosine equation whose graph would look the same as this. This is a great question. I want you to wrestle with this question. Put this video on pause, and then I'll try my best to make a great explanation. Put the video on pause. Okay, so it looks to me like what I've done is I got you to answer in Desmos, which is a really good plan. So let's see if we can kind of make sense of this one. So I'm going to try to type in the equation here. So I'm going to go, it's got to be a cosine wave. So I'm going to start off with a cosine wave. Well, I know certain things need to be the same, like the vertical displacement needs to be the same. And the period needs to be the same. So I'm going to go 2 pi divided by 20. So we've just got that looking the same. I'm going to put my cute little brackets around this so that I get everything I need in there. I feel like something's missing here. No, actually it's not. The other piece that I need to know is going to be the same, is it's going to be same height. And now what I need to do is sort of shift it over. So can you see that I basically just need to shift this thing back a little bit? So if I just go x minus 5, it didn't do it. Let's do this. X plus 4. Oops. What is the period of this? The period is, the period is 20. So basically what we just need to do, if you didn't catch that, is we just need to shift it back a quarter of the period. So notice that's what I just did. I shifted it back a quarter of the period. And so there's my equation. Okay, so if we wanted to do that with the sine, with the cosine wave, so let's look at this guy. So again, what I'm going to do is I'm just going to copy this time. I'm going to make this a sine wave. And when I do that, why didn't that work? Oh, too many y's. Okay, so there's my sine wave. So obviously what I need to do here is the period is 16, so I need to shift it back 4. So what would that be? I'm gonna add 4 to that, so that would be +1. I think that should do it. Oops, +1 will do it. So again, I just shifted it back a quarter of the period, and that's how cosine and sine are related. It's just a quarter shift of the period in one direction. So I hope that helped you. And there we go. So we've finished another section. Hope that's helpful. We'll chat soon.